Today we're talking about single displacement reactions. So I want you to get this down.
Do you need that?
Huh?
Do you need that?
Yeah. Oh, wait, no.
You sure?
Yeah, no. It's just the things for the sweatshirts. With a pen. My pen kind of just like, thank you.
Alright, we're ready? Okay, so now a single displacement reaction, what is this? It's when one element replaces another element in a compound. So, for example, in the first half of your worksheet, you saw that you have one element reacting with one other element, and you form a compound. In this situation, we have one element reacting with a compound, and then it replaces the metal, or, non-metal. So then, in this case, we have two types. We can have a metal replacing a metal, or a non-metal replacing a non-metal. So then we go back to our periodic table once we get a chance. So get that down.
How long have you had this eraser? 2 months. Really?
So this is our criteria. So when you see a reaction, you need to check if there are two metals, and if so, then there is a possibility there will be a reaction. And similarly, if there are two non-metals, then there's a possibility that they may switch places. So the format that this takes is A plus Bx reacts to Ax, reacts to give Ax plus B. So where are our metals? So we look at this periodic table, and our metals are somewhere to the left or the right of the staircase. Which is it, left or right? Left. So our metals are on the left of the staircase, and so then obviously the non-metals would be on the right-hand side of the staircase. So now we have the element A and the compound Bx. So I need two people. Let's see. Okay, I'll have Rachel and Miles come on up. And then, Rachel, I want you to stand right here. And Miles, you'll stand here. So pretend we're dancing. So I want you guys to No, you can do it.
Not that kind of dancing.
No, you won't be dancing. Just hold hands. So go ahead. You're compound. So hold hands. All right, and now third volunteer. So I'm going to have Derek. You can come up now. And you will be right over there.
Scared. I was like, I don't know.
So you switch places. You stand to her right. Okay, so now Derek is A, Miles is B,
Hold hands.
and Rachel.
No, not.
No. Just Rachel and you.
Oh, okay.
Yeah, and Rachel is X. So we have the boys. So now we'll have the boys being the metals. Okay. So they are a compound, and now Derek sees the two of them, and then he's like, "Oh man, I want to get by Rachel. I need to kick Miles out." So then, what's he gonna do? You're just gonna come and tell Miles to get out of the picture. And now they've reacted, and we have a new compound. So like, thinking this is like a new dancing partners. They're new dancing partners. Okay, and now Miles is like on his own.
Is that the demonstration?
Yeah, so that's how it would work. So,
Good job.
So we wouldn't have Miles wouldn't want to, or I should say Derek wouldn't want to be with Miles. He wants to dance with Rachel. They are both boys. They are both metals. Rachel is the girl. She's the non-metal. All right, thank you. Thank you very much. So now let's apply this to some real problems. So now let's go jump down to here. We'll have this one example I'll give you. So we have potassium reacting with zinc chloride.
What's in the second place?
What is that?
Okay, in the parentheses are the states of the compounds. So this is solid, and this is an AQ for aqueous. But don't have to worry about that right now. We'll learn about that later. So potassium wants to react with zinc chloride. Now let's, first of all, examine what we have here. So we have K for potassium. Now let's find potassium on the periodic table. Is it on the metal side or non-metal side? All right, so metals, check. Now, this has to be a metal if it's going, or one of these have to be a metal if any of them are going to react. So then zinc is one of them. So let's find zinc on the periodic table. Is zinc a metal?
Yes.
Number 50. Number 30. It is a metal. So then we have chloride, which is our non-metal. And now we have to see whether or not these will react. So then I want you to imagine with me now that we're at a high school called Activity Series High School, okay? And at this high school, the students are very, very superficial. So for example, we have this guy right here. Can you all see who this is?
I know who that is.
This is Chris Hemsworth. He's like the hottest guy at this school. Also very hot in
Chris
real life.
Hemsworth, you don't know who that is? Shame.
Is that why he's the most active?
Yes, he's the most attractive
Shame.
at this school.
He's Thor, yeah.
And
Shame!
and then we have now this little guy here. Anyone know him?
Wait,
Not very popular. And his name
he looks
is-
familiar, but I can't remember who he's
His name
from.
is Ugling. Yeah.
Because he's ugly.
I didn't think it
He's beautiful.
Alright, so
Maybe it could have been a Chinese name. We don't know.
this is the least attractive guy at this school. So girls really, they're so superficial, so they won't really want him because he doesn't look that great. So now we have to compare these to our guys. So all of these are guys listed at this school. So we have lithium, potassium, barium, calcium, sodium, and the list goes on. And we start at the top here. They're pretty attractive, and then they just don't get much better after that. So a girl would most likely, a girl non-metal, would most likely want to be with the ones at the top. Yes.
Do we feel like memorize that?
You won't ever have to memorize it. It'll be provided to you, but you will need to write this down for doing practice homework and stuff.
Not right now. Not right now.
Not right
Let her do her thing first.
All right, so then now we can compare that to this. So potassium, let's find him. Where's potassium on this list?
Second.
Second, right, he's right here. So then now we know that zinc is our second metal. So then we have to find zinc.
In the middle,
Where
it's
is
kind of
it?
attractive.
Ah, right here. So he's not that attractive. So think about a girl. Would she want to be with the potassium guy or zinc?
Potassium.
Potassium. So then now we have potassium trying to get with the chloride. So now, what's going to happen?
Chloride is going to want FK more.
Right, so then
Because
if
chloride's
they
pretty
are
shallow.
going to go in a battle, potassium will take zinc's place, and zinc is going to be out of the picture. So now potassium has replaced zinc, and there's a new a new compound formed. K, and we'll have Cl right there. Okay, so now remember, we never move the subscripts. We just take the actual ion and put it right there. So now, potassium and chloride. So we have to make sure to balance this now. So let's check for charges. So potassium,
+1.
group 1 means +1.
Chloride.
All right.
-1.
And now chloride, periodic table, it is
-1.
-1. Now, do these charges cancel?
Yes.
So do we need any subscripts? No subscripts. So then I'll just erase these little charges and put my next element here. So the metal is zinc, and now we have to check for the balance of the reaction. So now let's count through together. We have 1 potassium here and 1 potassium there. We have 1 zinc here and 1 zinc there. And now the chlorides, how many do we have left? 2. This little 2 tells us that there are 2 chlorides, just 2 chlorides. And so now how many is over here? Just 1. And so now we need to balance that. So where do we put our 2?
Saved it.
We don't put it here because this is for the charge. So then we have to put it here to balance the whole thing. So now we have 2 chlorides here and 2 chlorides there. But now we have a problem because we have 2 potassiums here. So then we have to add a 2 somewhere else. Right here? Okay. So at the bottom or in front? Okay, in front. So now I have the 2K, 2 potassium to give us zinc chloride, plus zinc chloride, produces 2 potassium chloride plus zinc. And now we're done. Yes, Kate?
So the states aren't part of our answer to the song.
Not right now.
No, not right now. Okay, so here's the second example. We have Ag, which is what? That's silver. Yep. So silver.
Way at the bottom.
And yeah, you already found it. He's way at the bottom. And then we react that with with sodium. I'm just gonna cross this out. And let's just have the Na3P. So now what's this compound right here? Sodium phosphide, right. So now let's check our activity series. Do we see sodium here? Sodium is right about here. Okay, so then that means that it's more reactive and this guy would be more attractive. So would phosphide want to react with silver?
No.
No. Okay, so then that means we have no reaction. So I'll abbreviate this NR for no reaction. And so we need to remember that this reaction did not occur because silver is lower in the activity series than sodium. So I want you to write this down.
So let me go back to the first one. Why did the first one react then?
Because it was higher than the other one.
It
The
potassium was higher than the zinc. So on a test, you will be given that activity series. You always have to look at that for single displacement.
All right, so I want you to start writing down this activity series in your notes.
Put it in your notes.
Write it in your notes. You'll need it.
Like she said, on a test that will be provided, but you will need that on your notes because you're going to need that when we do homework. You don't want it to be easy than looking at the picture all the time, wouldn't
It's kind of the same. I just paused it.
Go old school for the old guy.
Dun, dun, dun.
Does our band do that?
Sound like more combat.
Does our band go like this?
Sounds like more combat.
Does our band do that?
Yeah, cadence.
Do all bands do that or just ours?
It's pretty common.
Common? Because I thought Central Michigan did that too.
Yeah, but this is the one that we have. Well, like in parades sometimes.
Can we watch the egg explode before I put the yours away?
Yeah, I was gonna ask you if you're ready. I'm ready.
Multitask.
Don't miss the exploding egg.
I'm not ready yet.
Explode the egg.
Put your safety glasses on, because that's important. So here's what we did. So tell our viewers right now, don't do this at home.
Do this at a friend's
No,
home.
don't do it at any.
Oh, don't do it at anybody's
Just
home.
watch
Oh,
your
okay.
chemistry teacher do it, and you'll be fine. So here's what I did. I took eggs today, and I blew the egg out, which means that I poked a hole in one end, and then I poked a hole in the other end like this, and then I had to poke a pin in there, and then blow on it,
all out.
and blow all the stuff out. So it's the whatever. I washed my mouth.
The
All right.
long process.
So we need that,
Okay.
and then we're also going to need hydrogen gas.
But you make yourself. I have no idea you made your own hydrogen.
Well, you can. So we have an acid down here, and I have zinc that's here. So this
Does
is
the
just
auto
zinc.
industry know that this is this simple? Someone needs to call
No,
them.
this is probably expensive. So here we go. We throw the zinc inside. So you see
Oh,
how it's starting
and
to
here it
generate.
comes. Oh, look
Yep,
at
so
that.
there it is. So now we're going to put this over the top like this.
Oh,
So see how it's generating the gas?
That looks like
Right?
a fire department problem right there.
No, it's fine. So now here's what we do. Here, let's move this out of the way.
Yes, let's
Right?
do.
Oh, I got an idea.
Oh.
Why don't we take your glasses off
Oh,
for a
okay.
second?
All right.
Substitute them for the safety shield.
Oh.
All right. So get the safety shield on.
Oh,
Okay, so now I'm going to put the egg over the top like this. So you see how we're generating the hydrogen gas?
yes.
All right, good. So now I'm going to put my finger over the top
You know,
here
my
so we
heart's
have
left
gas.
unprotected. I'd like to point
It's
out.
fine. And so now we put this here like this. Got it?
Okay.
And so now I'm just going to light this.
Oh,
Okay. So now it's burning. So you see the little burning
I
that's
do.
there?
I
Doesn't make
do.
it sound good. So it's just burning, and so the gas is coming out. So the hydrogen's coming out, and oxygen.
Ah!
Is that kind of nice?
See clear.
So it takes it a minute to it's drawing out oxygen with the hydrogen. Is
Well,
that
so
what's
a little
going
bit of
on?
oxygen is coming in. You know?
Oh, I see. Oh, the burn. Right. Oh, okay.
So we're just generating hydrogen inside. So
How do you know when your egg is full?
You don't. That's why if I get it fuller, then it'll be great. That's what that red balloon is for. So if this goes over here like this.
Oh, we
So
can
I
really
think
tell
that's
it.
a pretty good one there.
Yeah.
Now
okay.
hydrogen is lighter than air, so it goes out. So here, let's. Oh, that's good. So you see how it's starting to.
I can
burn
see it.
just
I
a
don't know if
little
they can
bit?
see it on camera, but yeah. Oh!
Really, Rachel?
Do it again. That was really a good one. Do it
This is
again.
hydrogen gas in here. So you're trying
All right, we gotta stop. Desks.